This video is about the sine rule and the cosine rule and examples of the two cases of each, and also some brief discussion of applications of these. First, a note about clear reviewing when watching a video on TikTok. You might notice that when you watch a video, you have a list of items down the right-hand side of the screen and other things that come up that may interfere with viewing. If you long press on the screen, this menu will come up. At the top of the menu, this option, Clear Display, will remove all of that, which may make it easier to view certain things. Sine rule. So we have a non-right triangle, vertices uppercase ABC, sides lowercase ABC. Note that the side named is opposite the angle named. That is, side A is opposite angle A. Sine rule states small a over sine A is equal to small b over sine B is equal to small c over sine C. This rule is used when we have two angles and an accompanying side. That is, for example, a side which is opposite one of the two angles that we have, and we're looking for the other side. So, for example, we have side A, and angle B, and we're looking for side B. Here's a brief example. So we have a non-right triangle and we have angle C given 70 degrees and angle A given 75 degrees. And we have an opposing side for angle C, which is 12. To find side A, we can use the sine rule. A over sine of A is equal to C over sine C. A over sine 75 is equal to 12 over sine 70. A is equal to sine 75 times 12 over sine 70, or 12.34 to two decimal places. The sine rule for an angle. Again, we have the same non-right triangle with vertices ABC and opposing sides, lowercase ABC. By inverting each of the terms in the previous expression, we end up with sine A over small a is equal to sine B over small b is equal to sine C over small c. Brief explanation, 1/2 is equal to 3 over 6. If we invert both, we end up with 2 over 1 is equal to 6 over 3. Which is true. Therefore, when we have rational expressions which are equal, that is numerator over denominator equals numerator over denominator, if we invert both, they will still be equal. So the sine rule is used here when we have two sides and an accompanying angle and we're looking for the corresponding angle. So for example, we have side A and side C and angle C, and we're looking for angle A. Example, so we have, again, a non-right triangle with vertices A, B, and C. In this triangle, we have sides C, which is 51, and side B, which is 35. And we have the opposing angle to side C, which is 68 degrees. And we're looking for the opposing angle to side B, which we'll call theta. So using the rule, sine of B over lowercase b is equal to sine of C over lowercase c. Substituting in there, sine of theta over 35 is equal to sine of 68 over 51. Making sine theta the subject, sine theta is equal to 35 times sine 68 over 51, which is approximately equal to 0.6363 to 4 decimal places. So theta is equal to the inverse sine of that, which is approximately 39.52 degrees, the 2 decimal places.